One side of the spacecraft reached 2,500 degrees Fahrenheit. The other side, just inches away, stayed at a comfortable 85 degrees. Room temperature. That is not a typo. That is engineering. Crew, on December 24, 2024, a spacecraft from Earth flew closer to the Sun than anything humans had ever built. No astronauts inside, no one to repair it, no one who could reach it. It was alone, racing through the Sun's outer atmosphere at 430,000 miles per hour, fast enough to cross the entire United States in under 20 seconds. Then NASA waited. For more than 2 days, Parker Solar Probe was silent. No full update, no detailed message, just one question. Did it survive? Late on December 26th, a signal came back. Welcome to Astro Artemis. This is the story of the spacecraft that touched the Sun and survived. But Parker did not land on the Sun. The Sun has no solid surface. It is not like Earth, the Moon, or Mars. There is no ground. There is nowhere to stand. The Sun is a seething ball of plasma, superheated gas where atoms are stripped into charged particles. So when we say Parker Solar Probe touched the Sun, we mean it plunged into the corona, the Sun's outer atmosphere. And crew, that may be even more dangerous than a solid surface. This is where the Sun's magnetic fields twist, snap, and throw energy across the solar system. It is also home to one of the biggest mysteries in solar science. The Sun's visible surface is already blisteringly hot, but the corona, farther out, can be millions of degrees hotter. That makes no intuitive sense. If you step away from a fire, the heat should drop. But around the Sun, the outer atmosphere becomes dramatically hotter than the surface below it. Parker's Solar Probe was built to fly straight into that mystery. But first, it had to survive. The answer is a 4.5-inch thick carbon-composite heat shield. At closest approach, the sun-facing side of that shield reaches about 2,500 degrees Fahrenheit. Behind it, in perfect shadow, the instruments stay at a cool 85 degrees. Two sides of the same thin shield. One side is a furnace. The other side you could stand next to in a t-shirt. That is the genius of the mission. Parker does not fight the entire Sun. It survives by keeping that shield locked perfectly toward it, like a warrior holding one shield against a firestorm. If that shield turns even slightly off angle, the delicate instruments behind it could be exposed. And near the Sun, exposure is deadly. That is why Parker uses autonomous sensors to protect itself. Because out there, human reaction time means nothing. Commands from Earth take too long. By the time help arrived, the danger could already be over, or the spacecraft could already be gone. But heat is only part of the story. The corona is extremely hot, but it is also incredibly thin. There are not many particles hitting the spacecraft at once, so even though those particles are wildly energetic, they do not transfer heat the way fire or boiling water does on Earth. The real threat is the raw sunlight and radiation pouring off the star, and that is exactly what Parker's shield was engineered to face. So why take the risk? Why send a spacecraft so close to a star? Because the Sun does not just give us light and life. It drives space weather, solar wind, radiation, powerful storms. And when those storms reach Earth, they can disrupt satellites, GPS, radio communication, astronauts, and even power grids. Understanding the corona helps us predict those threats. And the better we understand them, the better we can protect the technology modern life depends on. Parker became the fastest human-made object in history. It flew where nothing had gone before. And after days of silence, it sent a signal back home. Crew, next time you look up at the Sun, remember this. That light has shaped every moment of human history, and now something we built has reached out and touched the edge of it. If you want more stories like this, subscribe. Next time, what secrets is Parker actually uncovering inside the corona? I'm Astro Artemis. Stay curious, crew.